Hi all, this is a session about the linear regression, basically the regression in data mining. So that is what we are going to see in this particular session. So we can have a quick look over to what is linear regression, how is it used in data mining. So in this session basically we will be talking about what is regression, what is how errors of regression is basically how error calculation is basically helping us in predicting the regression and predicting the values and the basic formula and how can we do it in RapidMiner and R. So regression analysis, so basically regression in mathematics itself means that what is the relationship between the dependent variable and the independent variable. Okay, so as we have already seen in the previous sessions of decision tree, we know what is a dependent variable. Okay, a dependent variable can be a target variable, and that is a what are we going to predict. Okay, and the set of the independent variables, the predictors or the attributes in your data set. So your normal attributes in your data set are the independent variables, and how these independent variables or the attributes will help us to predict the target variable. Okay, so this is what we are going to see. This has been the one which we have been seeing so far, and yet we have yet another process to understand this, and this process is basically linear regression analysis or regression analysis. Just let me take this hi Lisa. Okay, so this is the major crux of the regression analysis. Okay, and now so the major concept behind this regression analysis is that the whole analysis will help us to yield a predicted value for the criterion resulting from the linear combination of the predictors. Okay, so here we are talking about the linear. So why it is linear regression? Because it is a linear combination of the predictors, because in a data set we can have multiple attributes, and from the attributes or with the values of the attributes given, we are trying to predict. Okay, we are doing some operations upon the predictors or the attributes in order to yield or retrieve the predicted value or the target value. Okay, what are we going to infer from those linear combination of the attributes in order to understand a predicted value, whether what is the value that is going to be predicted for those combination of the attributes. The linear analysis, regression analysis, basically we need a data set. Of course we need a data set, and where we already know the target variable. So basically if we already know the target variable, is it's kind of we know the label right already, so that's supervised learning. Okay, and another thing which you have to keep in mind is that the attributes of the data the attributes of the data are numerical, and the target attribute is also numerical. Then basically we will go for the regression, linear regression. Okay, and if the attributes of the data are numerical or categorical, okay, if we can categorical or discrete, we can go for logistic regression. So basically there are two different types of regression. One is linear regression, which basically uses a straight line, and another one is logistic regression, which basically uses a parabola or a curved line. And these are the various application areas as we have seen in the previous previous techniques as well. So we can have trend analysis, time series prediction, okay, and the stock market prediction. So these are all basically works with the numerical values, forecasting and advice, marketing, biomedical modeling, environmental modeling. So all these things basically are the major applications. So in this time series analysis, forecasting, everything is major applications of linear regression or regression analysis. So basically when we look at the regression types, there are two different types. One is a linear regression and another one is logistic regression, which we have already told, and there is also one more thing called non-linear regression. So let me talk about non-linear regression. It will have this all the values will be basically like parabola and all those stuff. There is no it is basically polynomial ones where you have square, cube or whatever it is. Okay, and in the linear regression, as you all know, the equation of a straight line is y is equal to x plus b. So it's the same thing which is basically used here. So in if you have a single predictor, we go for linear, this will be our formula because ax plus b, where you already know that a is nothing but the slope, okay, the slope of the line, and x is the value which will be keep on changing in order to get this line, and b is nothing but the intercept, and this a is basically the regression coefficient. And say if we have multiple predictors, what would be the only change if it is linear multiple? Say that means that if we have multiple attributes, what we have to do is that a1 x1 plus a2 x2. So this x1 x2 are the various attributes, and a1 a2 will be the regression coefficients, and b will be the slope. So when we are actually performing this linear regression, if we want to find out the target variable is y. So if we want to find out the target variable, our aim is to find out the intercept and the regression coefficients. So we need to find out, once we get the regression coefficients and the intercept from the predictors. So x1 and x2 are the predictors, right? So we already know the predictors or the various attributes, okay, and from the attributes we need to calculate the regression coefficients and also what the intercept, because once we get this, what we will get, we will be able to predict the target variable. So this is what our whole concept is all about, and this is the mathematical formula. And in the logistic regression, only thing is that it's a classification technique. So basically it uses categorical variables which is of discrete type, so its formula is basically different. So this formula you have to use, that's all. And how can you find out the intercept of a slope or the slope intercept of the line? So how to calculate slope, or what is slope and what is intercept, that is what is basically shown. So this is one form of slope intercept which will tell you both. So your line is equal to y is equal to 2x plus 1. So how will you draw it? So 2x plus 1. So this y is the intercept, right? So this is nothing but the intercept. So this is your intercept and this is y intercept. So 0 to 1. So this is your y intercept, and 2x, x is your attribute, so you will put various values for the x to get the whole line, and you have this 2 is nothing but the slope. So this is your slope of the line, okay, this is the slope of the line, okay. So this is how you will actually interpret. So this is basically example for the slope intercept. Now, so in linear regression, as you all know now, you have various set of points. The major point which you have to do is that it is a line, right? We are going to find out a line which best fits all the data, okay, that is what we are going to do. But here our aim is to find out the best fitting line through the data points. So whatever be the attributes we have, whatever be the values of the attributes which we have, they are nothing but the data points. So we need to find out a line, okay, a line which will fit all the data points in the best possible way. So we need to find out the best fitting line. So how do you know that a line is best fitting line? We have already seen this earlier in one of our algorithms in PCA and all. So whenever we find out a line, we should make sure that the distance from the data point to the line has to be minimum. So that is basically called as error. That means the error has to be minimum. Okay, so this is how we will find out the line. We will find out, or we will call a line as the best fitting line if that line has got lesser distance to all the various data points. That means the difference between your actual data and the estimated data. Estimated data is nothing but when we when we plot this values onto this particular line, you will get a value. That value and the original value, the difference between this value and the predicted value has to be minimum. Okay, we have also seen the same in the confusion matrix, right? How to calculate the false positives and everything. And now how will you calculate the regression? So as I have already told you, y is the target variable and x is the predictor, which is your attribute, and this beta. So these are all different ways of representing the same formula, that's it. So beta is nothing but the intercept, and alpha is nothing but the regression coefficient, right? This is how it is. So they have just made it like this. So beta is equal to y bar. Y bar is nothing but mean, and minus alpha x bar. X bar is nothing but what? The mean for the x values attribute. So understand, this is the formula for the intercept, And now you should also have the formula for this alpha, and alpha is regression coefficient. You have already seen the Pearson coefficient and different coefficients before. So in the same way, you can use this as the this is the formula x1 minus x bar. Correlation coefficient we have already found, have already learned before. So the same one of the correlation coefficient you will use here in order to find out your alpha. So this is your regression coefficient. So x minus x bar, this is the common one which is used, y minus y1 divided by x minus x bar the whole square. Okay, so once you get your beta and once you get your alpha, you can substitute back in your formula, and this will provide you the regression line. So you can give different values of x to get the regression line. Okay, from that you can interpret. So for each value of attribute values of x, what would be the value of the predictor, that could be understood. The same representation, just in a bigger representation, that's all. So if this is your line, then your aim is to find out your b0 and also your b1. There are different types of representation for that. Okay, that's also all the same. So one is intercept and one is slope. So your aim is to find out the intercept and the slope. And this is one thing which you have to understand. So in linear regression, it could be a negative correlation, means negative line, or a positive skewed line. Non-linear, it will not be a straight line. And there are different type of regressions, so I have already told about linear regression and logistic regression. And there is another type of regression which is called as a linear regression and the multiple regression. That is nothing but if you have only one attribute, okay, then you could say that it is linear regression. If you have multiple attributes, then you could call it as multiple regression. So multiple predictors are there in order to find out the target variable y. And another thing is that the relation between the dependent variable with the set of the independent variables. So it's a linear approach to modeling. And in the case of so these are all some examples. You could just go through that later, and say if you have two or more independent variables and you are finding out one dependent variable, then you could say is that it is a multiple linear regression and could be continuous. This is actually an example of your iris dataset. So in the iris dataset, see here, if you look at it, you have versicolor, you have virginica, so, and this is nothing but setosa, right? So how each and every one is basically related, and how these two can help you to predict the values of your dependent variables. So all these things can be understood from here. And these are examples for that. So again, now we have already told that we need to find out the best fitting line for the regression model, and for finding out the best fitting line, we understood that we have to minimize the error. Now in order to calculate the error, we have different methods. So we have different methods for calculating the error. One is the mean squared error, root mean squared error, and mean absolute error, and each one has got its own specific formula as well. Okay, so when we follow this in mean squared, it is like you're taking the mean, so this slash is nothing but this dash is nothing but the mean. Okay, so the whole square. And if it is root, then you have a root over to it. If it is mean absolute, there is no square. Okay, there is no square. That's the difference between all this. So in everything, f of xi, it's nothing but the predicted value, or your y bar is your predicted value. That's it. Then we are going to find out a small example. This is actually taken from the internet, from one of the sites. So here you are basically having you're a small restaurant owner, and you have only one data with you. So in US, it is mandatory that whenever you go to a hotel, when you eat something, you will get the bill amount, and a certain percentage of the bill amount has to be given as the tips to the waiter or the person who serves the food, right? So that's a mandate. So now as the waiter or the owner, okay, you would like to develop a model. So you want to develop a model that will allow you to make a prediction about what amount of the tip to expect for given bill amount. So somebody have come here and eaten like $50 US, then what would be the tip that he will get? He want to understand that. Therefore one evening you can collect the data for all the 6 meals. So every evening you will be able to collect. Okay, so you have served for 6 different meals, and this is the 6 different bill amounts. Then how will you predict? Okay, what would be the bill amount? What would be the tip amount that you are supposed to get? So this is kind of a one variable example. So you have meals. This is the only data which you have, meals and the tip amount. even though your regression, your data is very less, because you have only one attribute. So what kind of the regression which you can use for you can go for a single regression, like linear regression, right? So when you look at it, the first thing is nothing but you have to plot all the data. Okay, you will plot all the data. It could be a scatter plot or whatever it is. So you will plot all the data. Then what is the next step? So you have plotted all the data. Once you have plotted all the data, then you have to find out b0 and b1, right? Now how will you find out b0 and b1? b1 is the slope and b0 is the intercept, right? So this is your y value, so you have to find out the y dash, right? So you will find out the mean of all these values, right? Now with only one variable, the best way is nothing but to get the mean. Okay, so you will take the mean and you will draw a line at your mean. Your mean is 10, so you will draw a line at the mean. Then what you have to do? What is the next one? So this is the line. Now you need to map the each and every data points to this particular line, right? So what you will do, the next one is nothing but you will plot each and every, so you will find out the distance between each and every data to the line. So you got so this is almost 4.5 and or 5, and this is 10, so minus 5, and this is 17 minus 10, so it is plus 7. So you got all this. So these values are basically called as the residuals, the difference, okay, between each one of them is basically called as the residuals. They are called as the residuals. So you can have positive residuals and you can have negative residuals. So in order to eliminate all this positive and the negative values, what you could do is that you can take the square of the residual. So that is the beauty in the so if you take the square of the residuals, what happens, all of the values will become positive, and you will get a larger deviation as well. So what you will do is that these are all the residuals and you are taking the square of them. So once you take the square of them, so it will look like this. Okay, so these are all the ones. Now what you have to do, so these are all the errors, right? Now how will you decide whether a particular line is best fitting line? Yes, the error has to be minimum, right? So for calculating the error has to be a minimum, you are taking all the error values, you are actually adding it, and you will get this. Okay, so now this is the for the mean, if the linear regression for this particular model, if you are taking mean as the line, this is the error. Okay, so now when you take some other line, then you need to make sure that you need to calculate the same, say if you're taking another line like this, okay, then you will map all the values onto it, then you will find out the error to that particular line, then you will square the errors, then you will sum everything, say whatever with the value which you are getting is, if it is lesser, then you will consider that line as the best fitting line. Okay, otherwise you will consider this line. If this is lower, then you will take this as the best fitting line. Okay, this is how it is basically done. Okay, hope you understood how we basically do the linear regression for one variable. Now just consider that multiple regression. So multiple regression, say if we have multiple data, you are not having only one attribute, you have multiple attributes. So what will you do? So you want to know what is the degree of the tip amount, okay, can be predicted by the bill. Okay, so this is the bill amount and this is the tip amount. So initially in the previous case we had only the tip amount. Now we have the bill amount. From the bill amount is also there, and the tip amount whatever is given is also there. So with this combination we will find out, okay, what is the amount to be gotten as a tip. So again it's all the same. So this is an all, don't worry by saying it. So again we have just recap the formula, and this is the criterion. What is your criterion? The minimum of your the distance, the difference between your actual value and the predicted value. This error has to be minimum. That's all. So this is our criterion as of now, we know. Now these are the values which are given to us, so we will again plot it. But as we have two different values here, what we will do is that we need x value and the y value. So x value we have taken as bill, and the y value which we have taken as bill amount. So for 34 the bill amount is 5. Like that we have plotted the complete data. Now we have multiple lines, so we don't know which line will be the best line. So we will try different lines, and what do we do? We will find out the distance of each and every value to each and every line. Now what we have to do? Now we will find out the correlation coefficient. So how will you find out the correlation coefficient? So the formula for this is basically um, uh, a1x plus a2x plus, like that it goes, right? So we will find out the regression coefficient. So if when we find out the regression coefficient, we will get it as r is equal to 0.866. Okay, and is that relationship strong? Yes, that is strong. So once it is strong, what we will do is that we will find out the centroid value. Okay, the best fitting value line should always fall through the centroid. So we will find out the centroid value, and then what we will do is, yeah, so we'll find out the centroid value, and for the centroid value, you know, yes, so we will find out the centroid value, and we will see whether which line basically pass through the centroid value with the least number of error. So that is how we will find out the what is that which line is actually best. So among from this line, which line is best. So each line we will find out the distance, and we will find out the minimum of the errors, and we will see which line is basically passing through the centroid and the minimum value. Okay, so now we are expanding our criteria. Okay, so that is what we are. So what is the correlation coefficient? So if the correlation coefficient is this one, we will use that. So yes, so it's very simple. So when we look at yeah, so now we are going to consider another example with lot of predictors. So if I have multiple predictors, what we could do is that, say you have total bill amount and the bill deviation, or say the total bill and the bill amount, right? So how can you calculate the correlation coefficient? That is which is basically shown here. See here, so you have two different values. One is bill amount and the tip. So exactly you have this bill amount and the tip. So what you will do is that, say if you are applying this particular formula, okay, what will you do? You will find out the x bar, you will have to find out the y bar, then you have to find out xi minus x bar, yi minus y bar, then the multiplication of that, and so you are just giving some values here, that's all. So this is nothing but x, you have calculated x bar, you have calculated y bar, then this is nothing but xi minus x bar. Xi minus x bar is nothing but the bill deviation, and this is the tip deviation, so yi minus y bar. So these two terms are over. Then xi minus x bar has to be calculated, then you have to multiply it and find out that one, and so this is nothing but this formula. This formula is basically the b1 is the slope for your for this one. Okay, so this is how, if you have multiple variables, you will find out the slope. That is also called as a correlation coefficient. And then the other one is the intercept calculation. So how will you find out the intercept calculation? So intercept formula is y bar minus b1x. Okay, this is your intercept calculation. Okay, so when you look at so this is you have your y bar here, so 10 minus then b1 we have already calculated from the previous case. It is basically this one. Okay, and say our centroid value, so this is where we use the centroid value. Okay, so centroid value is basically 74. Okay, centroid value is basically 74 here in this particular option. It is basically the centroid. So this is your your y bar is 10. Okay, and what is your x bar? X bar is basically the 74. So your x bar y bar is nothing but the centroid. Okay, so that value is taken, right? So you are basically applying this. Okay, so this is your y bar and this is your x bar. So you will be applying this, and you will get your centroid. This is intercept value. Okay, so this is your intercept value, and you will be assembling everything. So now you got b0, okay, which is the intercept, and you have also got b1, which is nothing but b1, which is nothing but the slope. So you will put it back into your formula. So y bar is equal to b0 plus b1xi. So you will be putting the values back into it, right? So this is your formula. So either you can write it as 0.1462x minus 0.81. So this is your linear regression line. This is the best fitting line. Okay, now in order for you to predict the value, what you have to do, in order to find out the target variable, what you have to do, you need to give the values for the for the attribute variable. So say so this is the best fitting line. So when you put each and every values onto this line, you will get the line. So what did you understand from this? So you can give different values of x, and you will each one will predict a different value of your y. So this is how the interpretation is all about. So always understand that for every $1 bill payment of x, okay, so if it is $1, okay, then what you have to do, you have to basically give something around 15 cents of a tip. And say if your bill amount is 0, this part is basically 0, then the expected or the predicted tip, so your x is 0, then basically you have to give like almost like negative 82 cents. So sometimes it doesn't make any sense, yeah, but that is how it works in the real time. But whatever you get, you can give your interpretation and keep it ready. That's it. And this is another example from Math This One. So this is, in this example I just wanted to show you that you can have different type of formulas, but all the formulas are all the same only. Okay, so this is sigma xy minus sigma x sigma y divided by, so this is your slope and this is the intercept formula, and your normal line is basically line equation is given as y is equal to mx plus c, and this m is the coefficient, b is the the intercept. Okay, so this is the regression coefficient, the correlation coefficient which you will find. So say Sam found how many hours of sunshine was how many ice creams were sold from the shop. So you have got two different predictors, two different attributes are there. Okay, and from that you have to calculate everything. So this is, you're calculating completely according to your formula, and you will find out the slope, and you will find out the intercept. Then you will again apply it back to your algorithm, your equation. And once you get the equation, so this is the best line. Okay, this is the best linear regression line for this particular problem. Okay, so in this, how will you find out each and every target variable? Yes, once you give different values for the x, you will get the best line. So you can put different 0, 1, 2, 3 etc. to find out your best line. So see, this is the best line. So accordingly, see, you are giving the values for x, and you will find out the value for the y, and you will get the error. So once you get the error, you can actually calculate the square of all the errors and see which is lesser. So that's all you can do. So always the minimum of the error, square of the errors, you have to make it as small as possible. That is your only job which you have to do. So which line has to be fit, that you will find out by, so if you have multiple lines, you have to find out the residuals of all the lines and to the data points, and then square it, and then say which of the line gives you the minimum error. So that line will give you this. Okay, so this is what it is. So this is how the linear regression. So you have to take the initial regression by attribute. It's you're like arbitrarily taking the, and then you're calculating the error. Then you're changing the value of alpha and beta. You can change the value of alpha and beta. Then you can find out whenever the error, say if the error decreases, then you go for that particular line. This is how you will test the data on your line. Okay. So that's all about the linear regression. So when it comes to the logistic regression, say one major example which I could say is that whether the government will win or lose. So it's a categorical type of data, and say whether the people will buy the product or not. So it is like 0 or 1. Okay, so whenever we have this straight line, basically it goes for the numerical data, and we use the linear regression. So if you have an S-curved data or sigmoid curve data, then we will go for the, basically we are going for the discrete data or continuous data. So at that particular time we will be using the logistic regression. So logistic regression is the process of obtaining an appropriate curve, okay, which will best fit the data when the target variable is discrete. And this is an example for the so it's a classification method again. So it is also called logic regression, and it's used for categorical. Your target variable is categorical, and independent variables or the predictors or the attributes, it can be both numerical or categorical, but your target variable is categorical. And so your final result could be the yes or no, or true or false, or 0 or 1. Okay, this is the formula which you have to use. So that's all it is for the time being, and hope you understood what is linear regression and logistic regression. So in linear regression, say you have got a data set, you're going with a set of data points, and each of the data point has got various attributes in that. So those attributes are basically the independent variables, and with the help of the independent variables you need to find out the target variable, the value of the target variable. So for that, if you have only single independent variable, then you could say that it is a linear regression, or you can also have multiple regression by using the linear method. And if you have multiple independent variables, then you can also go for linear regression by using the expanded formula. And if it is completely, the target variable is categorical, then you have to definitely go for the logistic regression, which will be a curve kind of a data. And here also in the linear regression you have you have various data points, so you will arbitrarily choose one particular line, then you will find out the distance of each and every data points towards the line, then you will find out the error, which is also called as residual. Then our aim is that the square of all the errors has to be minimum. So that line, say if you have multiple lines, you will follow the same procedure for all the lines, and you will see whether which line is having the minimum error. So that line will be the line with the minimum error will be taken as the best fitting line. And when you really look into it, you should also make sure that the line has to pass through the centroid value, and centroid values are nothing but your x bar and y bar, wherever it meets, and that is basically the centroid value. Okay, so this is all about the linear regression. So hope you understood, and it's an easier topic. It is very easy for us to understand and calculate. So thank you so much for the time being. So try to understand this in detail. So we will see how it works in RapidMiner and RStudio. Thank you so much.